Hi, a student asked me about this integral, so in this video, I'll be solving it. Well, if you're here watching this video, then chances are you've also tried a few things with this integral. So for example, you may have tried a u substitution where u is equal to x squared minus 6. That probably didn't work out too well because the x here becomes something complicated. You may also have recognized that this x squared minus 6 is a similar form to the trig identity. Secant squared minus 1 is equal to tangent squared. So you may have tried x equal rad 6 secant theta. Well, if you did that, then the inside the parentheses work out pretty nicely, but it doesn't help you deal with the ln on the outside. So here's a hint. When you're doing an integral, chances are you'll be trying many things, right? Well, here's me telling you that among the arsenal of things that you should always try when you're faced with a really hard integral is to do integration by parts with integral u dv, right? Where the u is the entire integrand. And the dv is just dx. Yep, that should always be part of the things you try. It's especially true if the integrand is a form of a composite function. And it is this fact that they are composite that's causing you trouble. You may think, well, that's kind of pointless. I mean, am I not just renaming x as v right here? Well, no, the point is that the u will transform. Yeah? So let me show you. The formula for integration by part is this. That's the formula. So I have my u, I have my dv. Now I need my v and my du. Well, v is just x. Now du. Du is the derivative of u, derivative of ln. It's 1 over. So this one is 1 over x plus square root of x squared minus 6. Except that there's an inside, it's a composite function, so I'll need to apply the chain rule. So I need to multiply by the derivative of the inside. Derivative of x is 1. Derivative of square root x is 1 over 2 square root x. Or you can do it as the derivative of power 1/2. So derivative of x to the power 1/2 is 1/2 x to the power 1/2 minus 1. 1/2 minus 1 equals negative 1/2. And negative 1/2 means square root in the denominator. Plus 1 over 2 times the square root of x squared minus 6. And again, the square root is a composite function. It has x squared minus 6 in the inside. So I'll have to apply the chain rule again and multiply by the square root of the inside, which is 2x. So the 2x goes here. And dx. Okay, I'm going to simplify this by taking common denominator. The common denominator is this, so 2 radical x squared minus 6. And when I take common denominator, the 1 becomes 2 times x squared of x squared minus 6 like that. And then plus 2x. Okay, the 2 cancel. Oh, I guess I could have canceled it back here. And now I have this quantity and this quantity that are the same. So now I can cancel them. So altogether, du is equal to dx over square root of x squared minus 6. Cool. Now I have everything. U, V, du, dv. I have everything to apply the formula for the integration by parts. So I'll go ahead and do that. The formula for integration by parts again. I have all my elements, so I put everything in. U is the ln times V is x. But I don't like putting the x in the back here because it's ambiguous as to whether or not it's part of the ln. Just to avoid any confusion, I'm going to put the x in front. Minus integral of v du. V is just x, and du is dx over x square root of x squared minus 6, so dx. This integral can be done with u substitution. Let's do that. I'll call this capital I. And I'll do u substitution with u equals to x squared minus 6 because the derivative of it is 2x, and that shows up here. I cannot use little u because I already used the letter little u, so I'll use the letter capital U. And to get 2x, I'm going to multiply by 2 and divide by 2 like this. Then I have my du on top. So my capital I is equal to du over 2 square root of u. And 1 over 2 square root x is the derivative of square root x, so I know the antiderivative of this right here is just square root of u. But I can also do it step by step by rewriting this as integral of 1/2 capital U to negative 1/2. And it is 1/2. Applying the power rule, the antiderivative of u to negative 1/2 is u to negative 1/2 plus 1. Negative 1/2 plus 1 is positive 1/2. And these cancel, so I get my square root of u plus c. And I substitute back the square root of x squared minus 6 plus c. That's my integral I. I put it back here. I have the whole answer. So let's write down the whole answer. That's the uv part in front, and then minus integral of v du, which is this. So you see that you should always keep as part of your arsenal the integration by parts where the u is the entire integral, or rather the entire integrand, and then dv is the dx. Let me scroll back up and show you why it's helpful. It's helpful because in the step of doing du, you break out, right? Because it's a composite function. In the process of taking du, you apply the chain rule and you break that g outside as a factor g prime. And it helps you get out of the whole complicated composite function situation. All right? Hope that helps. Any questions or comments? Put it in the comments section below. Like, share, and subscribe for more contents. And thanks for watching. Bye.